So here's my second attempt with this paper because the last time I tried to record it, I didn't turn the sound on. So I was basically talking to myself for 20 minutes. Let's have a look. So this is the paper 2 practice higher one. Okay, so this is your calculator paper. Okay, so still out of 80. It's not quite as bad as the paper 1, I don't think, so I'm going to do a bit more. There's roughly, last time I went through, there's roughly about 30 marks worth. I'm going to go through about 40 marks worth, okay, on this one, because it's not quite as bad as the other one, but let's have a look. Okay, remember, just as usual, I've written in red what everything is. So that's what you can revise if you need to. If you don't have this paper, which you probably don't, to be honest, then just pause each question and have a look at it yourself, and then you can unpause it and I'll explain it. Okay, so your first one is density. Now, we've done this before in class. There's a couple of formula triangles you need to learn. I don't know why that was such a bad triangle. One is that you have speed as distance over time. Okay, but your other one you need to learn is density is mass over volume. Okay, so density is mass divided by volume, so it's how we work out density. Units are some sort of mass, so something like kilograms over a volume, so it could be like meters cubed or centimeters cubed or something like that. Okay, there you go, that's density, you just need to learn that. Converting fractions to decimals. Now, this would be a tricky question on a non-calculated paper, but we've got calculators, which makes life a lot easier, okay? If I'm going from a fraction to a decimal, remember the middle line of a fraction means to divide. So the first one I'm going to do 23 divided by 75. Let's see what that gives me, okay? So my calculator here, 23 divided by 75 is 0.31-ish, okay? 9 divided by 4, I know that off the top of my head because it's 2 and a quarter, so it's 2.25. You can use a calculator if you need to. This one, if I do 19 divided by 8, again on my calculator, it gives you a decimal straight away. You might have to press the ST button to change it from a fraction to a decimal, but 2.375. So there you go. That's your answer there. That one couldn't be easier because you've got a calculator to do it. Let's look at the next one. Equations of straight lines. This is quite tricky. Let's have a look. I'm going to start by looking at a slightly different question. If I had the number 3 here on the y-axis and I drew a straight line that goes bang through the middle of it, okay, the equation of that line I've just drawn dotted is y equals 3 because it goes through 3 on the y-axis, okay? Now the x-axis is this thing here. So what if I did the same line as the one above? I just did it a little bit lower. Where is that cutting through? So this one cut through at 3, and this one's a little bit below. It's going to cut through at 0 there. So if the top one's y equals 3, then this one is x equals 3. No, it's not. Sorry. Reverse that. If that's y equals 3, this is y equals 0. Okay, so that's what you get there. Okay, so that isn't, confusingly, that is what the x-axis is. The letters have swapped over. This one, you can probably guess, would be the y-axis. Okay, right, let's have a look at the next thing. So angles and quadrilaterals. Let's look at what information it's given me. I know these numbers are going to add up to 360 because it's a quadrilateral. What have we actually got? We've got the 2 angles are the same, okay? So that's the only info I've really got to go off on this. Let's have a look at these pictures. So the first one's kites. In a kite, you always have these 2 angles that are the same, okay? In a parallelogram, these will be the same, and these purple ones will be the same. So that is 2 pairs that are the same. A rhombus is going to be the same as that. A rhombus is basically a parallelogram. It's just a wonky square rather than a wonky rectangle, okay? And then trapezium, you get a lot of different trapeziums. Well, that's one sort, and that would have 2 pairs that are the same. They're not the most common ones, probably. This one below it does have 2 the same, but they're both right angles, so they'll both be 90, so it's not going to be a trapezium, okay? It's going to be a kite. So a kite is one that has just one pair of angles the same, and they're always those 2 ones opposite. Top and bottom aren't the same ever, okay? Let's keep going. Elevations of shapes. So what is this telling us? We've got a solid cuboid. It's made up of centimeters cubed. The plan view, that just means the top view. So if you looked at it from the top, you'd see this. the front view, so if you looked at the front, and the side, if you looked at it from the side. Okay, how many centimetres cubes were used to make this cuboid? Another way of asking that exact same question is, what is the volume of this cuboid? Okay, so how many centimetres cubes means what is the volume of it? Let's have a look at what we've got on this. I'm going to label each length of each side. Okay, so this goes 4 up, and that's 6 across. The next one is 3 up, and it's 4 across. This one is 3 by 6. What I'm really after is, what is the length, width, and height of this thing? Well, what numbers have I used? I've used a 4, I've used a 6, and I've used a 3, and the rest of those numbers repeated. Okay, so the length, width, and height are 3, 4, and 6 in whatever order you want. Okay, if I wanted to work out the volume, it's length times width times height. Okay, so I'm just going to times these in any order I want, and I've still got a calculator, remember. 3 times 4 times 6, which is 12 times 6 is 72. So there were 72 cubes. Okay, if it asks you what the volume was, which it hasn't, but if it did, you'd have to write 72 centimetres cubes. Okay, but it's just asking how many cubes, which is 72. Okay, it's not too bad, that one. Right, 6. I went through a harder question on the same thing on the last one I went through on the last video, so this is an easier version of that. Okay, averages from a group table. Let's just highlight a line and we'll talk about what this means. Okay, so frequency means how many. So there were 20 people who spent between 4 minutes and 6 minutes at a supermarket checkout. Okay, because that's what this table's showing. So 20 people took between 4 and 6 minutes. If you took exactly 6 minutes, though, you would have to be bumped into the next one, because this thing means here that it could equal 6. Okay, so if you were bang on 6, you would have to move up to the next group. That's how this works. Okay, let's have a look. So the median, remember, is the middle. That's what we're trying to find out for the middle, the median, the middle. There were 80 people, there were 80 customers, so the middle is roughly the 40th person. Okay, so basically what group is that 40th person in? Let's have a look. First 32, so that almost takes us up there straight away. We're in this first group. If you had 8 more people, that's going to bump you into this next one. Okay, so the 40th person is somewhere between this 19 lot in here. Okay, because the first 32 are there. If you went up by 8 or more, then it's going to take you into the next group. So it's taking me into the second group. So the median is the second group, which is that one. Okay, that's roughly where the 40th person is going to lie, somewhere in that group. Okay, I don't know what exactly number it is, but that's how these tables work. I just know it's somewhere in that group. The manager of the supermarket says 90% of the customers wait less than 6 minutes. Okay, I'm just going to rub out what I've got in this table. Less than 6 minutes, so that is, these ones here are between 6 and 8, so it's not them, it's everybody else. Okay, so these people were between 4 and 6, so they were all less than 6. These were definitely less than 6, and these were definitely less than 6. Okay, so how many people had to wait less than 6 minutes? I've got 32, add 19, add 20. Okay, calculate time. That gives you 71 people. And it says something about here, 90% of our customers. Basically, it is that 90%. There were 80 customers, remember? So I'm going to do this. Similar to how we did that question before. 71 out of 80. I'm going to do 71 divided by 80. So as a decimal, that equals 0.8875, okay? If I want that as a percentage, I need to times by 100, okay? So that's going to be 88.75%. Okay. Does this data support the statement? Was the manager right that 90% of our customers wait less than 6 minutes? Well, no. I've got enough working out there. No, he's not, because there's only 88.75 were. Okay, that's quite harsh for 2 marks, I think. It should be more than that, but there you go. Okay, no, he wasn't right. Not quite, anyway. Okay. Right, frequency trees. Sometimes these are really nice and straightforward. This one's a bit more complex, so let's have a look at it. 50 people took a test. That's why there's a 50 here. So this is always the grand total, that number on the left. And then we've got this, people who predict their predictions of the test and then what actually happened in the test. That's what these 2 bits mean, okay? And it says 30 people predicted they would pass. So pass, the prediction was they would pass. So that must go there, okay? And this is how frequency trees work. These two lines will always have to add up to 50. Okay, these two boxes will always have to add up to 50. So if I know one's 30, then the other one must be 20. And you've got 1 mark for doing that, which is the really easy bit, okay? Now, this is a bit more complex. 36 people did pass. So you might think that 36 needs to go here. Well, for one, that wouldn't make any sense because only 30 people predicted they'd pass, so it needs to be less than 30. But 36 people did pass could be these 2 yellow boxes. So everyone in these yellow boxes did pass, basically, okay? So those 2 numbers have to add up to 36. Of these 36 people, 3 times as many predicted pass as predicted fail. So let's have a look what that means. It means that this top box has to be 3 times as big as the bottom box, okay? And together, I know they need to add up to 36. Now, there's 2 ways to do this. One's a bit more mathsy than the other. One way to do it is just to try a number here. So if I try the number 10 here, well, the number above it is 3 times that, which would be 30. Now, what do those 2 numbers add up to? 30 add 30 add 10 makes 40. So no, that one doesn't work. Okay, so I'm going to just try a different number. That's one way to do it. And if you keep going with that, you'll get the answer eventually. Here's how to do it a different way. I've got 36 people, and I'm going to split them in this ratio, okay? I've got 1, and then 3 times that is 3, so I want to split that in the ratio 1 to 3. That means the numbers on the right are 3 times as big as the numbers on the left, okay? Here's how you do that. You do 1 add 3, so add the numbers in the ratio, which is 4, and you do 36 divided by 4, which is equal to 9. And this is your magic number. This is what you need to times your ratio by, and that will give you 9 and 36 if you times both those numbers by... it'll give you 9 and 27. And those 2 numbers add up to 36, so I know that I'm right with that, okay? And I'm going to put these numbers in here. You would have got that number quite quickly if you had just carried on doing what we call trial and error before, okay? Let's finish this off. 27 adds something makes 30, must be 3. 9 adds something makes 20, that one must be 11, okay? And that's that question done. Here's a money problem. Okay, so Thomas ran a Lucky Dip store and it gives us the rules here. So 50p to play. Any ticket ending in 00 wins £12. Any ticket ending in 5 wins £1.50. Bit more info. So there's 750 tickets in total. He sold all the winning tickets and some of the losing tickets. And then he made a profit of 163. Okay, so before we do anything else, so let's think, how is he making this profit? He's selling a load of tickets for 50p, so that's how he makes his money, but then he's giving away prize money. So I'm going to do how much money he makes from the tickets, take away how much prize money he gets, and after that I know he's left with 163. Okay, let's actually try and work some stuff out, shall we? We're going to start with this bit. Tickets ending in 00 win £12, and it says that he sold all of the winning tickets. So he sold all of the tickets that end in 00. And the tickets went from 1 to 750. So the first one that would win would be ticket number 100, and then 200, and then 300, blah, 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 all the way up to 700, which would be the maximum one, okay? So there are 7 tickets that win, how much do they win? £12 each, okay? So that's the easy bit, okay, or the easier bit, okay? Let's look at the harder bit, which is this. Tickets ending in £5 win £1.50, okay? Well, what's the first ticket that ends in 5? Okay, it'll be ticket number 5, and then it'll be 15. And if you could be bothered in the test, you might write all of these. I'm going to go up to 100 with them, okay? 45, 55, 65. So they're occurring every 10, okay? So every 10 tickets, there's a winning ticket. Whoops, what am I doing? 95, okay, that's our last one, okay. So between 0 and 100, there are 10 winning tickets, okay. So between 1 and 750, you win every 10 tickets, okay. So I'm going to be left with 75 tickets that win £1.50. Okay, so like I said, if you could be bothered, you might even write out all of them, but every 10 tickets wins this one ending in 5 prize. Okay, so there must be 75 of them. Right, let's work out how much money he's given away. So in prize money, he's given away 7 lots of 12 quid. They've won the jackpot. Okay, so they've got 7 times 12, which is £84. But then quite a lot of people have won some money, so 75 times £1.50. Easy calculator. It's £112.50. Okay, so the total of that, if I add those two winnings together, is £196.50. Okay, that's how much money he has to give away. So he gets his money by selling tickets, then he has to give away £196.50, but he's still left with this profit of 163. Let's write this down. Okay, so his profit equals his ticket money. So how much he's made from tickets, minus his winnings, okay? Or the winnings, the jackpots people have won, okay? So let's write this down. £163 is equal to whatever his ticket profit is, minus, we just work this out, £196.50, okay? So I'm trying to solve this weird little equation I've got. If I basically do 193 add £196.50, that's how much money he's made through tickets, okay? So the ticket money is equal to those two yellow things added together. 163 add £196.50. So through selling tickets, he has made £359.50. Okay, let's go back up a sec. Each ticket was 50p. Okay, so if I divide this thing by like £0.5, which is how much each ticket is, okay, it tells me that he sold 719 tickets, okay? Right, let's just go back a second and look what the question is. How many losing tickets did he sell? So he sold 719 in total, but I need to take away everyone who's won, okay? And remember, I'm going to get the highlighter right again. It's a bit of a mess, this question, isn't it? I'm going to take away this because they won, and I'm also going to take away that because they won. So I'm taking away 7, and I'm also taking away 75, okay? So I'm basically taking away 82, okay? 719, take away 82. Tells me that there were 637 losing tickets. Excuse me. Okay, so that's that question finished. Remember, that's quite a lot of marks. That's 6 marks. Okay, so even if you can't get this final answer, you should definitely be able to get some sort of method marks throughout that somewhere. So you should be picking them up as you go. Okay, right, let's keep going. This is an absolute gift if you see it. You need to look out for this question, okay? Write 280 as a product of its prime factors, okay? This will come up definitely at some point of your higher papers somewhere. Question could be paper 1, 2, or 3, and you need to be able to do this, okay? So 280, and I'm going to split it up. So I need 2 numbers that times to make 280, okay? The only rule when you do this is you cannot ever use the number 1, okay? And the reason for that is that 1 is not a prime number, okay? Because it only has 1 factor. Let's think 2 numbers that times to get 280. I'm going to make it easy to start with. It's 2 times 140, okay? Now 2 is a prime number, so that gets a ring around it, okay? This is called a factor tree. 2 numbers at times to get 140. You can do this whichever way you want. I'm going to go for 14 times 10. Okay, neither of those are prime. They can be split up. So 14 is 2 times 7. Both prime. Done. But 10 is 2 times 5. Okay, so I've circled everything. So I've got my... they're all what we call prime factors. This word product, remember, means times. So what I need to do is write all these out times together. My answer is going to be 2 times 2 times 2 times 5 times 7. Now that will get you full marks, but I don't really like this thing here, so I'm going to write it a bit better in the answer bit. That'd be 2 cubed times 5 times 7. that is us finished, okay? I don't need to work that out. If I did work out this little thing here, I do have a calculator, it'll give me 280, okay? So that is my method here. This is how I work it out, and that blue bit below it is the answer, okay? You need to be able to get full marks whenever you see this product to prime factors thing, okay? Do a factor tree and then times all the circled things, okay? Question 7. Expand and simplify. So my class has done this fairly recently. I'm just going to write it a bit bigger over here, okay? Because I haven't got much space there. Y plus 5 times by y minus 4, okay? And what we do is we multiply everything in the left by everything in the right. So what I mean by that is I'm going to do, first thing I'm going to do is y times y, and then y times minus 4, okay? Y times y is y squared. Y times minus 4 is minus 4y. And I'm going to shift over. So I've got 5 times y and 5 times minus 4. So you always get 4 things from these are the 2 brackets, okay? So you get plus 5y, and then you get minus 20. Okay, you get the highlighter out. The only bits that it can bring together are usually in the middle, but it's in this case the 2 y bits, so it's those two, okay? My answer is going to be y squared. What is minus 4y add 5y? It's minus 4 add 5 is 1, so it's like positive 1, so it's like plus 1y, or just plus y, okay, and then minus 20. That is your answer, okay? So that's another sort of basic thing that you need to be able to do on a higher paper, definitely, okay? Expanded double brackets, okay? Next one. Right, next one, we haven't done this, my class, okay, so don't expect you to do this, don't expect you to learn it just before a mock, but I will go through it anyway. So if you want to skip this for now, feel free, but I'll go through how you would do this, okay? So this is called trigonometry, and I know it's trigonometry because I've got a right angle triangle, I've got 2 sides, and more importantly, an angle, okay? If you didn't have an angle, you'd probably be using Pythagoras at this point to work out the next one, okay? So here's what we do. We need to label up the sides, and our options are the hypotenuse. We've got adjacent, okay, so adjacent is another word for next to, so that your next door neighbour lives adjacently to you, for instance, okay, so that's what adjacent means, just, or who you're sat next to, just means who you're adjacent to, and your one is opposite, okay, so just missed that off, so opposite, okay. Right, let's look at what we've got here. I've got this long side, and it's opposite where the right angle is. That is always your hypotenuse, okay, so this side is a H for hypotenuse. And then the 8, if you look where my angle's in this corner here. The side that is next to it, that isn't the hypotenuse, is the one that's adjacent to it, okay? This one over here would be opposite, but I don't care about that because it's got nothing on it, okay? It's got no numbers or letters or anything, so I don't care about that one, okay? And then here's what you need to know. You need to know these little formula triangles. So, ka, toa, okay? And I need the one that has the A and the H in, which is, I'll try and draw a triangle around it, is this one here, okay? So that is the only one I need, the middle one for this, okay? What we're trying to work out, we're trying to work out the angle, which in this case is the C. This is going to be harder than the question below it, okay? But we'll do it anyway. I'm going to work out this C thing, and the C stands for cos of whatever the angle is. So cos x equals, and using my formula up top right, I've got A divided by H, which is 8 divided by 11, okay? So you can work that out if you want, but it gives you pretty nasty decimals, so I'm not going to. Actually, I'm just going to leave it for now. That's what cos is. That's what cos of this angle is. If you want to undo that to work out what the actual angle is itself, which is what we want to do, we have to do what we call the inverse cos of this. So I type on my calculator cos minus 1 of 8 divided by 11. Make sure your calculator has a letter D at the top and you're working in decimals, but you press Shift cos 8 divided by 11. And it gives you, I'm just going to do it to one decimal place because it doesn't really tell me what to do it to, but so I'm going to do 43.3. That's how many degrees I get for that, okay? That's finding an angle which is, if anything, harder than below. I'll show you why. Okay, let's have a look at below. I've still got this opposite adjacent thing. Let's have a look. This thing would be the hypotenuse, but there's nothing on that side, so I'm not going to write that H, okay? What I need is the Y, which is opposite. Okay, it's opposite the other side of where that angle is. So my angle's up here. And then the 37 is the one that's next to it, but isn't the hypotenuse, it's the adjacent one, okay? So in this one I'm going to write these again, I know they're just up there, so Toa. I want the one that has the O and the A in, which is this last one, okay? What we're trying to work out on this one, we're trying to work out this O at the top. Let's just rearrange that formula. So O equals, that's not a 0, it's an O, A times T, or T times A. And A is 37 times by T, which means tan of whatever the angle is, so tan 40. That's what you need to type in your calculator, okay? 37 times tan 40. Which gives you 31.0. This is what it gives you, 31.04668, blah, 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 okay? You might want to write that whole thing. I'm just going to write 31.0 because that's what it would be to one decimal place, and that's how I did the other one, okay? If it doesn't ask you, just do it to something sensible, like one decimal place is absolutely fine, okay? Right, that's trigonometry. We haven't done it before. If that made sense, fantastic. If it didn't, don't lose any sleep over it because we will be doing it at some point, okay? Let's keep going. 12 is to do with cylinder volume, okay? First we need to know what sort of shape a cylinder is, okay? And a cylinder is a prism. Oops. Okay, a cylinder is a prism. And a prism means that this 3D shape, if you look, it has a circle on the top, and if you were to cut it anywhere in the middle, it would also have the same circle. That's a really bad picture, but you get the idea. It's got this same circle going the whole way through it, okay? And if it has that, it's what you call a prism. And this is how you work out the volume of prisms, okay? The volume is the area. So the area, for instance, in this case of the circle, so the top, and you times it by the height, okay? So let's work that out. I'm going to rub out all this, whoops. I'm going to rub out all this stuff here. Let's have a look. So all I care about is this area of the circle, right? It gives me here what halfway across is. Remember, that's the radius. Okay, so the area is equal to pi r squared, which is equal to pi 3.14 times 40 squared, okay? Now, if you type that exactly in your calculator using the pi button, it will give you this, okay? 40 squared is 1,600, so it will give you 1,600 pi. I'm going to leave it like that for now because that's fine, okay? So the volume is equal to the area times the height or the length. So this is 1,600 pi times by 150. Again, just stick with your calculator. It will give you a massive number, 240,000 pi, okay? If you use the pi symbol, it will just stick that on the end for you, okay? Right, what do we need to do here? So that is in centimetres cubed. Okay, I'm going to stick with working with pi because I think it's easier, but if at this stage you want to, just do 240,000 times by 3.14 times by pi, and you can get an actual number of what that is, okay? But I'm going to stick using pi for now. I've got this thing here that 1,000 centimetres cubed is equal to 1 litre, so I need to divide this thing by 1,000, okay? And if I do that, I'm taking off 3 zeros, so I'm going to get this 240 pi litres. That's how many litres we've got, okay? It is filled at a rate of 0.2 litres per second, okay? So every second it fills up by 0.2 litres. Here's what I'm going to do. I'm going to do 240 pi, on my calculator this is, divided by 0.2, and that will tell me how many seconds this thing takes. So 240 pi divided by 0.2, and it gives you 3,769.9 seconds. Does it take longer than 1 hour to fill? Well, we need to know how many seconds there are in an hour. Okay, so let's think. 60 minutes in an hour. So it's 60 lots of 60. Yeah, because every minute is 60 seconds, and there's 60 of them. So let's work out what that is. 60 times 60, that gives you 3,600 seconds. That's 1 hour. So does it take Does it take longer than 1 hour to fill the tank? Is this number bigger than 3,600? Yes. Okay, that's fine as an answer. If you want, you could do one, take away the other, and say something like it takes 169.9 seconds longer, okay? But otherwise, that's fine. You don't need to write anything else than that if you compare the two things, okay? Where are we up to? Question 13. I think we're going to go to about question 20-ish on this, okay? So we'll keep going. Right, this thing here, and people always ask what this is. You see how it's not an equal sign, it's got 3 equals bits to it, okay? This thing is called an identity. So if you ever see that, it's called an identity. And what it means is the left-hand side of that equation or identity is always equal to the right-hand side of that equation, no matter what values of x you put in. It'll always be the case. I mean, we know that because in our class we've done this. X times x is x squared, and x times 4x is 4x. It doesn't matter what value of x you have, it will always be equal to that. So for how many values of x is that equal to that? It's an identity, so it's always equal to that is the answer, okay? If it only has 2 equal signs, then it's always the case, okay? It'll be an equation, and it won't be that they all equal it, okay? But there you go for that. Let's move on, shall we? Okay, Sophie buys birthday cards. She has 30% profit to the cost price. She sells the cards for £2.34 each. She wants to increase her profit to 40% of the cost price. How much does she sell the card for? Right. She has added 30% to how much it costs her, okay? So we start with 100%. That's what the cost price is, and we've added 30%. So what I have here is that 130% is equal to £2.34. Okay, this is what you call reverse percentages. Okay, I'm going to shove the word reverse up here. So that £2.34 isn't 100%, it's 130%. We need to work out what 100% actually is, okay? Here's the easiest way to do that. If I divide both sides by 130, I'll get what 1% is. Okay, so I'm going to do 2.34 divided by 130. And it gives me 0.018. Okay, I know you can't actually have that money because it's like 1.8p, but we'll carry on. I don't want 1%, I want to know what 100% is. That's the whole point of doing this, okay? So times both sides by 100, and 100% is equal to £1.8 or £1.80, okay? That is what you call a cost price. Okay, right, let's finish off this question. She wants to increase her profit to 40% of the cost price. What I basically want to do is take this number here and I want to add 40% to it, okay? So there's a million ways to do this. Work out 10% and keep adding them on if you want. Another way to do it is you times it by £1.80. If I times it by 1.4, that increases it by 40% because 100% add 40%. Here's 140%, and that's 1.4 is a decimal if you divide it by 100, okay? So £1.80 times 1.4, this will tell me how much she needs to sell it for. She needs to sell it for £2.52 if she wants to make 40% profit, okay? So it was 30% over, work out 1%, work out 100%, and then we need to add 40% onto that. However you want to do that, you should always get £2.52 at the end, okay? It's called reverse percentages, that. Bit of standard form. We get into the pretty hard questions now, okay, but let's have a look. This number here, it wants us to write it as 3 bits in standard form all added together, okay? If I was to break this number down that I'm highlighting in yellow, if I was to break that down, you could say that it is 6,000 add 6 add 0.6, okay? And so that's what I'm going to do. I'm going to write these 3 numbers in standard form. So let's go. The first one, I get 6 times 10. How many numbers are after the 6? There are 3 numbers, so that's how you write the first one. Plus 6 times 10. How many numbers are after the 6? Well, there aren't any numbers after the 6, so that must be a 0 there. That's a bit of a strange one, that. Plus... And then if it's a small decimal, you write 6 times 10. And with these, it's basically how many zeros are at the front. And there's 1 0, but instead of writing to the power 1, I need to write -1 for those small numbers. That's how they're different, okay? So what we got here, we've got these three numbers. So 6 times 10 to the 3, so that must be a 3. 6 times 10 to the 0, so that's 0. And then 6 times 10 to the minus 1 is what our last one was. You can have those three numbers in any order, okay? Because I could have done, yeah, you could have moved them around. It wouldn't have made any difference, okay? Question 16. Equations of straight lines. You need to know this. That any straight line is written as y equals mx plus c, where this m thing is what we call the gradient, okay? And that tells you how steep it is. So in this case, let's just have a look at it. Y equals something x plus c. The only bit I really care about for this question is that the gradient, I'm going to write here that m is equal to 5. Okay, right, if I know the gradient's 5, it has a steepness of this. If I know another one is parallel to that, it must have the same steepness. So it must have the same, so if they're parallel, it means that they have the same gradient, okay? So on our new one, the gradient is also equal to 5. Okay, I'm going to write it out similar to how I wrote the bit out before. So y equals mx, so it's 5x plus c. I just don't know what this c is, okay? But luckily it gives me some coordinates to try and work this out with. So I've got a pair of coordinates here. First number is your x value and your second number is your y value. And I'm going to substitute them into this equation here. So y is equal to 5x, so minus 4 is equal to 5 times x, which is minus 2, plus c. Let's try that again. Minus 4 equals 5 times minus 2 is minus 10, plus c. And then if I want to work out c, I need to add 10 to minus 4, basically, okay? And that will give you 6, so that's what c is. Right, so now we need to put everything together. Y equals mx, I know what m is, it's 5x, plus c, I've just worked that out, 6. That is the equation of that line. That's tricky, that question. Let's have a look at this histogram question. Okay, so Joe asked 230 students how long it took them to travel to school, and it's got the table here. So 44 people took between 0 and 5 minutes, for instance, okay? So he's made this little table, if you go down, is this little chart, sorry. And the first one goes from 0 to 5, which is what it says on the table, and it's gone up to 44 at the top, okay? Which is all great. Right, let's have a look. Make 2 criticisms. Sorry, I've jumped ahead on this. Make 2 criticisms of this histogram. Well, the main thing is that this is not a histogram that he's drawn. He's basically just drawn a bar chart, okay? This is roughly what a histogram should look like. You get sort of bars, and some of them are long and some of them are tall, and then you get big fat ones like this, okay? That's roughly what a bar chart looks like, okay? It's lots of uneven sized blocks is essentially what it should look like, whereas his are all nice and the same width, okay? So here's one criticism is the bars. I'm going to write it a bit easier than I did last time. The bars shouldn't be an equal width, okay? That's one thing that's wrong. So you should have some really long ones, and if you look, that is from 30 to 60, so that one should be way longer than the first one, which only goes from 0 to 5, okay? That one should be way more spread out, okay? What else has he done wrong? Question 2, you shouldn't have frequency on the y-axis. It should be, so frequency should be what we call frequency density. That's what you call the thing on the y-axis, okay? And then one more criticism that I'll make. There's probably quite a few looking through it if I look through a bit more carefully, but this isn't how histograms work. You don't just go up to the frequency. What you need is the area of this to equal 44, okay? So it's a rectangle, so 5 times something should equal 44, and then you work it out that way. So basically, I'm not going to even work that out. I'm just going to say that the area of each bar should equal the frequency, okay? don't spend loads of time on that question. If you don't understand that, don't worry, we'll do histograms at a later date, okay? I am going to do this one though, cumulative frequency, even though it did come up on paper 1 annoyingly, but let's have a go at this, okay? Draw a cumulative frequency graph. I'm going to label this next one CF for cumulative frequency. And cumulative means that you add up as you go along, okay? So I start with 0, and then I'm going to add the next number. I'm going to add 9 to get 9. Then I'm going to add 35 to get 44, sorry. I'm going to add 30 to get 74. I'm going to add 18 to get 92. And then you should get a nice round number at the end. We get the number 100, okay? Right, I need to plot this on a graph, which is a bit annoying because it means I'm going to have to go back and forth, but let's have a go, okay? So, here's what we do. The lowest value here is 0, so what I do is I find 0 here. It's not always in the corner, but it is there, so 0, 0. Then I go along to the upper limit of each one of these and plot it with this, okay? With the cumulative frequency, sorry. So along to 80 and up to 0. And then I go along to the bigger number, so I'm going to use a highlighter here, so along to 100, then up to 9. I'm going to just plot as I go along, okay? Along to 100 and up to 9 as best I can is there. Then my next one is along to 120 and up to 44, which is really badly drawn, 120, and then 44 is exactly there. And then 140, 74. And then the last two are 160 to 92. And then 180 to 100. Okay. And you should get, with these, it roughly makes that shape when we're done, okay? So that's roughly what mine are looking like, so I know I'm done. Let's join them up without using a ruler. That's dead important, okay? So it should be nice, free line like that. And usually you would have to join it to that M1, but I don't think you actually do for this, but there you go. That'll do. That's our cumulative frequency graph. Estimate the number of these films with a running time less than 2.5 minutes. Really, I need a ruler for this, but I don't have a ruler because it doesn't work on this. 2.5 hours. Well, 2 hours is 120 minutes and half an hour is 30, so it's 150 minutes, which is there. So what I need to do is go, imagine that this was with a ruler. I'm going to go right up here until I hit my cumulative frequency graph. And then as soon as I hit it, I'm going back off to the left. Okay, you do this really similar to what you do with the line of best fit. This is really not neat at all, but it takes you to there, okay? Estimate the number of these films a running time of less than 2.5 hours. So I want everything less than here, basically, okay? And that hits exactly at 84, so my answer is going to be 84, okay? That's how you do cumulative frequency graphs in about 5 minutes. Let's keep going. This is the last thing I want to do because we did do it in class, so I thought I may as well go through it. Okay, let's have a look. So question 19, last one I'm doing. W is directly proportional to Y. So what I do whenever I see that is I write an equation. I write W equals KY. Then it says W is inversely proportional to X squared. So I'm going to write W equals K over X squared. That's how this one gets written as an equation. And that's how you'd write this one as an equation. Okay, when this one talks about Y and W, so I'm going to be using the first one because the second one has X in, which I don't need, so I just need this one for now. Let's write out this equation again. W equals KY, I'll need that. When Y is 4, W is 14. So when W is 14 equals K times by Y, which is 4. If I want to know what K is, I need to do 14 with a calculator, 14 divided by 4, which normally needs a decimal. And it gives you 3.5. Okay, now I'm going to rewrite this thing, but I now know that K is equal to 3.5. So I have that W equals 3.5 times Y. Work out the value of W and Y is 9. So I need to do 3.5 times 9, okay? And it gives you 31.5. Okay, next one, it's given me nicer numbers maybe, but I've got a worse equation. I'm going to use what's I labelled as 2 with a circle in at the top. So W is inversely, always means K over, and it says inversely to X squared, so it's K over X squared. Now I'm going to shove the numbers in just like I did. 10 equals, don't know what K is, that's what we're trying to work out first at least. 10 over X squared, which is 2 squared, which is 4. Okay, so to work out K, I need to do 10 times by whatever 2 squared is, which is 4. So I know that K is equal to 40. Okay, let's rewrite the first thing. So W equals 40 over X squared. Work out the value of W when X is 10. So W equals 40 over 10 squared, which equals 40 over 100. And just do on your calculator, 40 divided by 100 is 0.4. Okay, that's that. That's worth a lot of marks if you can do that. And if you look at some of the other questions I've done, the amount of work isn't as much. Okay, you just need to know what that directly proportional, inversely proportional thing means, really. Okay, and then be quite good at substituting as well. That's what we need for that. Which graph shows the relationship between Y and X? Let's have a look. Oh, this is quite a bit harder than what I thought it was. I will do it. I'll give you the answer basically. I've got these two equations. I'm going to do my working out here. W equals KY. And your other one is W equals K over X squared. If W equals KY and W equals this, then these two things of underline must be equal to each other. So KY would have to equal K over X squared. Okay. If I divide both sides by K, I get that Y equals 1 over X squared. And which of these graphs is equal to 1 over X squared? I don't necessarily expect to know that, but it is D. Okay, just for closure, that's what that is. That is a very hard question actually for 1 mark, but it is multiple choice. Okay, so that's your backup. Okay, right, that's enough for that. See how you get on with those. Good luck.